All right, so this is the test review for graphing equations and systems of equations. So before we start, remember whenever we're graphing, it's always going to be in our slope-intercept form, which is usually represented as something looking like this. Y is equal to some number times x, and then plus or minus some number. That number multiplying with the x is always going to be what we call our slope. Okay, that is the rate in which our line is going up or rate in which our line is going down. Okay, and then the number that's adding or subtracting is going to be the y-intercept. Okay, so that is the point where our line crosses the y-axis. Okay, so if we look at this problem right here, this is just a single equation. Again, we look for that number that's multiplying with our x. That would be this 9 over 5. And remember, slope is always going to be, this is usually represented as a fraction. If it's not a fraction, if it's a whole number, then we would just put that over 1. But this is a fraction, it's 9 over 5. Okay, so that's going to be our slope right there. Okay, then our y-intercept would be this number that's adding or subtracting, and it's plus 4. So that's our y-intercept. Okay, when we graph, we always start at our y-intercept. So we're going to go to positive 4 on the y-axis, and that is the point in which our line is going to cross the y-axis. So I'm going to start right there. Okay, now slope is 9 over 5, so that is a positive number. So you guys remember slope dude, when he's going uphill, that's more work, right? That's going to create a positive slope, and that is the puff, puff, positive, right? Because he's having to do more work going up the hill. If he was going downhill, that's where he was just skiing, and it was a nice negative, right? Nice negative. Okay, so this is a positive slope. So when we think of positive slope, that means that it should be going uphill, it should be going up from left to right. Now, positive slope, that means that you're going to go up and to the right in order to get it to positive, right? Both these numbers are positive. Those are both positive directions on the y and x axis. However, that is off our graph here. If we go up 9 over 5, that's over here. It's off our graph. So if we wanted to go backwards, we would have to go the opposite directions, right? We'd have to go down 9, left 5, and we would end up back at the point we started. And we can do that on this graph as well. We can go backwards and go down 9, left 5, and there's a point that I can graph that's on my graph. And then to finish our line, we just connect the points. There's a line right there. Okay, now there are two special types of lines. We have, if you guys remember, sloped it again. We had the zero fun, and then we had the undefined as well when he fell off the cliff. Your favorite part. Okay, now when we are doing the zero slope, that is, both of these are only going to have one of our variables. The zero slope is just going to have a y equals some number. And then the undefined would be x equals some number. This is the only line that's going to have no y. Okay, so if we come back here to number 1, y equals 5, that would be a zero slope at 5 on the y-axis. So it looks something like that. And then on number 4 here, x equals 0, that would be that vertical line just right there at 0 on the x-axis. So basically the y-intercept would be that line right there. Okay, then if we come over to this side of our review, you'll notice that we don't have these in our y-intercept form. So in order to be in the y or the slope-intercept form, the y needs to be all by itself. Okay, so we're going to have to solve for y basically here. So if we look at this problem, on the same side as the y right now, we have that negative 5 multiplying with the y, and then we have this plus 5 right here. So what I'm going to do is I'm going to treat it kind of like a party problem. This would be my best friend, this would be my acquaintance. I'm going to get rid of everything. So the y is going to be my host, and I'm going to want to solve for that one. So at a minus 5 from each side, because that's my acquaintance, that's going to give me 6x minus 5 is equal to negative 5y. Now looking at this, I need to get rid of my best friend now. So I would have to divide by negative 5. Now remember guys, I wanted you guys to write this as, instead of just all being under negative 5, I want you to do it to every term so we can focus on it being to this 5 going to every term in the equation. Now negative 5 divided by negative 5 are going to cancel out. I'm just going to be left with y on that side. Negative 5 divided by negative 5, that one's going to be reduced to a positive 1. And then I have 6 over negative 5. I'm going to just leave that as a fraction because, again, that's my slope right there. So 6 over negative 5, one of them's negative, one of them's positive. That's going to make a negative fraction, right? So it's going to end up being negative 6 over 5x. That's a 5 plus 1. So looking at that, the number that's multiplying with the x is my slope, so negative 6 over 5. And then the number that's being added or subtracted is my y-intercept. So that would be 1. So I'm going to start at 1. And since this is a negative slope, it should be going down from left to right, right? So remember, with negative fractions, basically one of your numbers is going to be negative, one of your numbers is going to be positive. So if I go down 6, that's a negative direction. So if I go down 6, that means I have to go to the positive 5, so to the right. And hey, look, that's going to create a downhill line there, right? You go up 6 into the left 5, but that's also going to be off the lines or off the graph. So we'll just continue the line, and there's your graphed line right there. All right, so that's graphing equations. Now on the back here, this is where we have systems. So systems equations, it's basically the same idea. You're going to be graphing lines onto the graph. You're just going to have more than one graph. Now, the point of systems is to find the point where they intersect. The point is the point. Okay, so if you, let me give you some examples of a system. So a system, you might have like some intersecting lines like this. Okay, right here, this point, whatever that is, that's what we need to figure out. This is what we'd call a one solution system, and that solution would be the point where they intersect, the x and y coordinate there. Okay, so there are 3 types of systems. This is one of them. The other type of system you might run into are parallel lines. Okay, we think about parallel lines, they don't share any points in common, right? So if the point is to find the point, there is no point with parallel lines, right? How many times can I say point? So there aren't going to be any solutions for this one. So this is an example of no solution. Okay, and then the last type that you'll run into is going to be some overlapping lines. So if we think about that, they're lines right on top of each other. They're basically going to share every point with each other. And if they go on forever, that means they would have infinite number of solutions. Okay, so those are the 3 types. So let's look at this first example here. So let's look at this one. So we have, when we graph these systems, we just do a one equation at a time. So y equals negative 2x plus 3. This would be my y-intercept. This would be my slope, right? So I would start at 3. My slope is negative 2 over 1. So I'd go down 2 over 1, down 2 over 1, etc. Okay, so that would be that first line right there. Second equation would be negative 4 would be my y-intercept, and my slope is again going to be negative 2 over 1. So it'd start at negative 4. I can't go down 2 over 1, so I'm going to go up to left 1. And that would be my second equation. So I look at these lines, they are parallel, right? And again, I could figure that out just by looking at my equations. They have the same slope. If they have the same slope, that means they are increasing or decreasing at the same rate. If they're going at the same rate, that means they're going to never touch. So parallel lines, remember, are going to be no solution. And that would be my answer for this one. Okay. Let's look at our next example here. So looking at this top example, the y-intercept is -4 right here. And my slope is going to be -4 over 1. So -4 over 1, I could go down 4, right 1, but that's off the graph. So I've got to go backwards, so I'm going to go up 4, left 1, up 4, left 1, up 4, left 1. There's going to be my first line right there. Notice I made all these points a little big because we've designed these equations to all meet at one of these points that we plot out using our slope. Okay, so that's going to be one example there. So let's look at the next equation. It's -x plus 2. 2 would be the y-intercept. My slope, there's no number there, right? But anytime there's no number next to the x, there's an invisible 1 there, right? So I'm going to say the slope there would be -1 over 1. So I could go down 1 over 1, but that's away from the other line. So I know they're not going to intersect there, so I'm going to go up 1, left 1. Hey, look, they intersect right there at that point. Now to figure out that point, I need the x-coordinate. Looks like the x-coordinate is going to be -2. And then the y-coordinate would be 1, 2, 3, 4. So 4, where a pair would be -2 and 4. There's my answer. Okay, not too hard, right? And then the last type of problems you'll run into on this review are going to be the systems where you have to solve for y. So let's look at number 14 here. So 14, we have x plus 4 is equal to 0. Now this one is a little bit different because there's no y to solve for, right? But remember, there is a certain type of equation that I didn't have to solve for y, right? Or didn't even have a y. And it's my undefined type line, right? So if there's no y, that means it has to be an undefined type line. In which case I need to get the x by itself to figure out where my undefined line is. So I look at that to get the x by itself, I would just -4 to each side. -4, and that's going to give me x is equal to a -4. So x is equal to -4, that means the undefined line is going to be a -4 on the x-axis. So I've already got one line. And then down here, I've got -1 plus 3 over 4x equals -y. So the y isn't quite by itself yet, right? I need a positive y for the y to be by itself. So I got to get rid of that negative in front of the y. So what I do is I divide it by -1, because you got that invisible 1 in front of the y. And then I just do that to every term. Now when I divide by -1, the numbers are going to stay the same. All that changes is the sign. So that 1 is going to become positive. That 3 over 4x is going to become negative. And then the y becomes positive. So looking at that, my y-intercept is going to be 1. And then my slope is going to be -3 over 4. So nice negative, I could go down 3 over 4. But the line's over here, so I'm going to go backwards. So I'm going to go up 3, left 4. And right there is where the two lines intersect. So I need that point of intersection. So it looks like it's intersecting at -4 and +4. Okay,